Welcome to Edexcel International A-Level Mechanics 1. This is Mr. Mina Bowles, and today I'm going to solve the January 2023 exam paper. Question 1. A train travels along a straight horizontal track between two stations A and B. The train starts from rest at station A and accelerates uniformly for t seconds until it reaches a speed of 20 meters per second. The train then travels at a constant speed of 20 meters per second for 3 minutes, before decelerating uniformly until it comes to rest at station B. The magnitude of the acceleration of the train is twice the magnitude of the deceleration. On the axis below, sketch a speed time graph to illustrate the motion of the train as it moves from station A to station B. The question starts with the train start from rest at station A, which means when t equals 0, u equals 0, speed is 0. Accelerate uniformly for t seconds until reaches a speed of 20. So it's starting from 0, accelerate uniformly till it reach a speed of 20 meter per second, and that will take t seconds. So that distance here is t, and our point here is t. After that, the train moves with a constant speed, 0 acceleration for 3 minutes. Since our speed is in meter per second, this means the distance must be in meter and the time should be in seconds. I have it here 3 minutes, so I multiply 3 by 60 to change it into seconds. So it will be 180 seconds. So the train moves with constant speed, 0 acceleration, for 180 seconds. So from this point to this point here, that will take 180 seconds, which means our point here should be t plus 180. The train then decelerates uniformly until it comes to rest at station B, so it will go from 20 back to 0. But the question is saying that the magnitude of the acceleration is twice the magnitude of the deceleration, which means that line here, the gradient for that line should be twice the gradient for this line. So this one will be more steeper than this one. So I will draw a line here that is less steep. If it takes t seconds to go from 0 to 20, and the acceleration is twice the deceleration, this means to go from 20 to 0, that will take 2t seconds, which means our point here will be t plus 180 plus 2t, which is 3t plus 180. Part B. Stations A and B are 4.8 kilometers apart. Our distance must be in meters. So 4.8 multiplying that by 1000 to change it to meters, so it will be 4,800 meters. For the speed time graph, the area under the speed time graph is equal to distance, which means the area for that shape will be equals 4,800. I can split it into two triangles and one rectangle, or I can just do it as one full trapezium. The area for the trapezium, it's 1 over 2 brackets a plus b multiplying by height. A and b are the two parallel lines, which means this line and that line. That line here equals 180, and that one here equals 3t plus 180. And our height will be 20. So now we have 1 over 2, a, which is 180, b, 3t plus 180, multiplying by the height, which is 20, equals the distance between the two stations A and B, which is 4,800. Let's solve this equation for t. Half multiplying by 20, that's 10. Divide 10 on the other side, so that will be 480. Simplify that. 180 plus 180, that will be 360. Subtract 360. So 3t will be 480 minus 360, which is 120. Divide by 3. 120 divided by 3, that will give us 40. And we don't need to include the unit here because the question at the beginning is saying that it's accelerate uniformly for t seconds, which means the value for t here is just a number. I don't need to include the unit. Last part. Find the acceleration of the train during the first t seconds of its motion. So I need to find the acceleration as it goes from 0 to 20. The acceleration or the magnitude of the acceleration is just the gradient for that line. And the gradient is just rise over run. So my rise here is 20, my run here is t. So the acceleration for part C, acceleration will be the rise, which is 20, divided by the run, which is 40, which is 0.5 meter per second squared. Or we can use SUVAT. I can use SUVAT to find the acceleration. It starts from 0 till 20. It takes t seconds, which is 40, and I can find the acceleration. Let's put the information. Displacement or distance, I don't have it. The train starts from rest, so our initial velocity is 0. Reach a speed that is 20, so our final velocity is 20. Acceleration, that's what I need to find. Time, it takes t seconds, which we found at 40. Let's apply SUVAT. So from these four, I can use v equals u plus at. Our final velocity, which is 20. Initial is 0. A, which we need to find, multiplying by t, which is 40. So we have 20 equals 40. A divided by 40. So A will be 20 divided by 40, which is again 0.5 meter per second squared.